Okay, so let's rationalize some of these higher degree, these higher root, higher index radicals, right? So remember we said that the concept of rationalizing, of simplifying radicals was that you are not allowed to have a fraction under the radical. And so when I look at this expression, 5 over ab squared, I'm going to look at this and say that's not simplified because there's a fraction underneath the radical. And so we had a property that allowed us to give this radical, this cube root, to the numerator and the denominator. So I'm going to say this is now the cube root of 5 over the cube root of ab squared. Okay? And so I'm looking at this and say, great, I fixed my problem. No more fraction under the radical. But it's still not simplified. And so the reason this isn't simplified now is because now I have a radical in the denominator. And so I need to make this go away. And so now your job is, I'm going to figure out what do I need to multiply the denominator by so that it is a perfect cube. And so it's a little bit tougher to think about. We're really going to look at this and go term by term and say, I need to multiply this by some cube root of something. And I'm going to look at this and say, how do I turn a into a perfect cube? And we said if you want to simplify perfect cubes that have variables and exponents, the idea is that that perfect cube would have to have some multiple of 3 as an exponent, right? So a to the 3rd or a to the 6th or a to the 9th, those are things that I can cube. So if I want to turn a into one of those, I need to multiply it by a squared, because a times a squared is a cubed, and I've succeeded. I've done what I needed to do, and that's going to cube root. I can do the same thing with b squared. If I want to turn b squared into a b cubed, I want to multiply it by just a single b. Right? So we need to multiply this. We're going to see how it works out in a second, but we need to multiply this on the numerator as well. Okay? So this is now a squared b on the numerator as well, the cube root of a squared b. So let's simplify this. This is now the cube root of, well, 5 times a squared b is just 5a squared b. That doesn't simplify at all. We can just put them all under one radical because we had a property that said as long as the index numbers on the radicals are the same, you can multiply the radicands together. And so what I'm going to get in my denominator now is the cube root of, well, a times a squared is a cubed, and b squared times b is b cubed. And so that looks like the cube root of a cubed b cubed. And we said we're allowed to simplify these expressions by dividing the exponents by 3. Since they're both divisible nicely by 3, we made that happen. This is going to simplify nicely. So I'm going to say in this case, the numerator is going to stay the same, the cube root of 5a squared b. The denominator now is going to become, well, a cubed. I'm going to divide that 3 by the index. So that's just going to become a to the 1st. No more radical because I took the cube root. And the same thing's going to happen with b, and it's going to become b to the 1st. So I can say the simplified way of writing this expression using our criteria for simplified radicals would be to turn it into the cube root of 5a squared b all over ab.